Okay, so let's talk about gases. And I don't think we'll get through this whole chapter. We're running a little short on time, but the good news is there won't be a test. So relax and enjoy. So, why are gases easier to compress than solids or liquids? And it has to do with the packing of those molecules. In a gas, they are easily compressed into a smaller volume because there are mostly empty space between the atoms or molecules of the gas, and we can decrease that. Gases are easily compressed into a smaller volume. This is called compressibility. And this is essentially how your airbag works. That guy's a really bad actor. And so the airbag absorbs most of the energy from the impact of the collision because when you hit the airbag, you're able to compress it, and that transfers some of that kinetic energy to the air in the airbag. So the volume of the particles in a gas is small. The gas molecules themselves or particles are very small compared to the overall volume. So the distance between the particles in a gas is much greater than the distance between a liquid or a solid. Liquids and solids are in contact with each other. Under the increased pressure, the particles in a gas are forced into a smaller volume. That means they're closer together. So here we have two containers. They both have the same amount of molecules of nitrogen and oxygen. If we have a larger volume, the molecules are further apart. If we compress it into a smaller volume, then they become closer together. And this roughly approximates the oxygen-nitrogen ratio in our air that we breathe. So, explain why air is easily compressed, but what is not? Well, it's because the volume of the particles in a gas, such as air, is small. The particles are small compared to the overall volume, and so the distance between the particles is much greater than the distance between a solid, such as wood. And so gases can be compressed and solids and liquids can't. In fact, that's how the brakes work in your car, is there's a long column of fluid in your brake line, and as long as that's uninterrupted, your brakes will work fine. If there's a small hole and some gas gets in there, all of a sudden your brakes won't work. That's not a good thing. So there are three factors that affect gas pressure. And in fact, there's four values or four variables in an equation you're going to get. And the fourth one is pressure. So the four variables are the number of moles, the volume, temperature has to be in Kelvin. All calculations in this unit will be in Kelvin. So remember, you just take the Celsius and add 273 to it. They have pressure here in kilopascals, but I'd like you to change that to atmospheres. So the amount of gas, volume, temperature are the factors that will affect gas pressure. So how can you use kinetic molecular theory to understand or explain how gases will respond to changing conditions? So if you inflate an air raft, for example, the pressure inside the raft will increase. That's why it gets more and more difficult to blow into an inflatable. Collisions of the gas particles with the inside walls of the raft result in the pressure that is exerted by the enclosed gas. Increasing the number of particles, because you're blowing air into the raft, will increase the number of collisions, which explains why the gas pressure increases. So we've changed the number of moles of particles. So here we have a tire pump. We have a container. And as we inflate the container, the pressure inside increases because the number of particles is increased. And if we double the number of particles, then we will double the pressure. And that tells us that pressure and number of moles are directly proportional. And we can eventually put too much pressure on it and it will explode. and then the pressure will quickly decrease. If the pressure of a gas in a sealed container is lower than the outside pressure, then the air will rush into the container when the container is opened. If the pressure of the gas inside a sealed container is higher than the pressure of the outside atmosphere, then the gas will flow out of the container when the container is unsealed. An example of this would be like opening a bottle of Coke. We know that if it's good, when we open that bottle, we'll hear the release of gas, and that fizz will happen inside the container. An aerosol spray can works the same way. The gas propellant up at the top portion of this gas container is very high pressure. We have our paint, and it has a tube. That's why we have to make sure we don't try and tilt the can upside down, because we need that paint at the bottom of this tube. We depress the valve, which is what opens, then we'll have aerosol paint come out, or spray paint. You can raise the pressure in a container by reducing its volume. If the gas is more compressed, then the pressure that the gas exerts inside the container will increase. Increasing the volume of a gas will have the opposite effect. So if we increase the volume, the pressure decreases. So we call these being inversely proportional. As one goes up, the other goes down. So here we have a plunger, and if we push down on the plunger and we decrease the volume, we see that the pressure increases. So they are inversely proportional. Temperature. Kinetic molecular theory will explain what happens as gas is heated. As the temperature increases, the average kinetic energy of the particles increases, and the faster moving particles will strike the walls of the container with much more energy. And pressure is actually a measurement of how strong or what velocity those particles impact the walls of the container is pressure. And so if they're at a higher temperature, they move faster, they hit the walls with more force or energy, and that would increase the pressure. So increasing temperature increases pressure, so they are directly proportional. So here we have a measurement of the temperature. If it goes from 300 to 600, the pressure would also increase, and it would double. If we increase the temperature too much, we can actually break the container and it will explode. So, how does the pressure of a container of gas change when the volume of the gas is increased? So, if we increase the volume, what will happen? And the answer is the pressure will decrease. So, what do you think would travel further if you kicked with the same amount of force? A properly inflated soccer ball or an underinflated soccer ball? And they say the answer is a properly inflated soccer ball will travel further. And this is why if you are in the NFL and you go to Denver, kickers love Denver because they can kick for much further distances because the atmospheric air is less compressed, and even though the football's inflated the same amount, it will travel further, and so they can kick longer field goals. And I'm not going to address the Patriots and football pressure. What might happen to an overinflated soccer ball if you kicked it too hard? Well, if you kick it too hard, it could burst. So we're at the end of this unit. Gases are easily compressed because the space between the particles is great. The amount of gas, the volume, the temperature, and the pressure will affect the pressure. Compressibility, the measure of how much volume of matter decreases under pressure. So, thanks for watching.